Uh, okay, students, example number 4 says using first principle differentiate cube root of sin x. So this again we have taken first fx is equal to cube root of sin x. In place of this x, if I am writing x plus h, then in place of this x it should be x plus h, that is cube root of sin x plus h. So d dx of cube root of sin x is written as limit h tending to 0 fx plus h minus fx all divided by h using the first principle formula. So in place of fx plus h, we have written this sin 1 by 3, that is cube root of sin x plus h is written as sin to the power 1 by 3 x plus h minus sin 1 by 3 x. Now you can see a clumsy multiplication is done over here. As you can see, it is in the form of a minus b. So if you are multiplying to this one, a minus b into, that is what I am saying is this a minus b into a square plus ab plus b square, then it will become a cube minus b cube. So in place of a we have sin 1 by 3 x plus h, and in place of b we have sin 1 by 3 x. So because of that a square, in place of that we have this whole thing, and ab in place of that it is this thing, and b square is this. I hope you can understand the reason behind this one. So this much is multiplied in the numerator and the same thing is multiplied in the denominator, and this h is copied as it is. So carefully you have to see this thing and understand. So in the numerator, as you see, it is in the form of now a minus b, and this is a square plus ab plus b square. So in the numerator it becomes a cube minus b cube, that means the cube of this sine to the power 1 by 3x plus h and cube of sine 1 by 3x. So finally this 3 are getting cancelled, that is this much and this one. So we are left with sin x plus h minus sin x, which is written over here, and the denominator is copied as it is in the denominator over here. Now you see in the numerator we have sin c minus sin d formula. Using that, it becomes 2 sin a minus b divided by 2 into cos a plus b whole divided by 2. This x are getting cancelled, only h is left, that is sin 2 sin h by 2, and this h is divided by 2 and multiplied by 2, so that this whole thing, when h tending to 0 will become 1, which is what I have written over here, and these two are getting cancelled. In this part, if we are applying the limit h tending to 0, then this becomes cos 2x plus h, this becomes 0. This 2 will get cancelled, and so that we are left with in the numerator as cos x, and in the denominator h becomes 0, this h becomes 0, this okay, this plus this will become 3 multiplied by sine 2 by 3x. I hope you can understand this whole thing. Thank you.